My name is Matt Fontana. I'm from Swift Solutions. We're a SolidWorks reseller. So we span across the US. I'm based in Colorado. So jumping in here, we're going to be talking about top 10 tips and tricks on how to manage your CAD data. I'm going to be taking a little bit of an agnostic approach to this in terms of just file management, some data management, just general practices that pretty much anybody could use regardless of your system as well. A little bit of background about myself here, though. I'm from Michigan originally, South Central Michigan. I got my degree in mechanical engineering. I got started with SolidWorks in contract design engineering. So a lot of different industries, a lot of different types of projects could come onto my desk and give me a really broad range of experience getting into all the different aspects of SolidWorks. I then moved into Swift Solutions in 2020 and then focused on 3D Experience solutions. And if you're unfamiliar with 3D Experience, you might hear the terminology more and more. It's a big concept, so it can get confusing on what it really is, but you can think of it as Dassault Systems family of products. SolidWorks is one of them. So SolidWorks is just a child under that whole 3D Experience portfolio. So SolidWorks is a big focus of mine specifically. Now, as I mentioned, I am in Colorado. I do go back to Michigan for a lot of time in the summer for all that lake time and family, but I like to get all my hiking, camping, and skiing in for the rest of the year. So today we're talking about data management, file management. This is a really interesting article by Tech Clarity. There's some interesting statistics here. 48% of time on innovation and design work where we really want to be spending our time. 20% could be business development, other things that are good to know, but aren't necessarily towards innovation design work. But we have 32% of our time on non-value added work. And this was over a survey of, I believe it was thousands of engineers across the industries. And it resulted, they polled people on what this non-value added work people were losing time on was. And it was things like searching for information, collecting data for other people, incorporating changes made by others, recreating data you couldn't find, or working on out-of-date data as well. So if you don't have good practices, these can make you lose a lot of time in your day-to-day workflows, and it can be really important to make sure you cut these down as much as possible. Then we can take that 32% of time that we're wasting on these activities and incorporate it into our design work. So I've been alluding to this quite a bit already, but data management, file management, and how I'm going to discuss this. First, just a little bit about data management. Make sure that your data is organized, files are organized, make sure it's usable downstream. That's kind of a summary of what it really comes to. If you can use the data and other people can collaborate on it, that's really what it's all coming down to. And this will help you reduce your non-value add activities. It's going to help increase your security as well. You don't have the chance of deleting data as easily, things like that, controlling who has access to edit it, making sure that the wrong person isn't editing the wrong data. And then we're also going to help take that time and decrease our time to market because we're going to have more value added time. But what I'm going to do with each of these tips, I'm going to have a somewhat consistent format. I do have a version of this at 60 minutes and I stripped it down a little bit to 30 here, but we're going to start with a tip. Some of them have a little bit of background prior to showing some workflows. Then I have some pre-set up workflows that are between different theoretical people so we can see how that works in an organization. We'll start with a worst case scenario, no practices whatsoever. We'll jump into an improved scenario where you're just implementing, you're still working out of a file-based system, Windows File Explorer, but you're at least using some better practices to make sure that you're optimizing your workflow. And then we'll take a look at data management. I specialize in 3D Experience data management, but these practices are general. So if you have SolidWorks PDM, really whatever you're using, these practices are more of just a general guideline of how you can guide your workflow. So starting up, number one, understand how SolidWorks references files. The longer you get into this, the more familiar you become with it just by trial and error. But especially if you're newer to SolidWorks, I suggest taking some time and learning about the file references to make sure that you're not breaking them on accident, wasting time going back and fixing broken file references. A big thing with this is a SolidWorks search routine. If you're not familiar with this already, I won't go super in depth with this, but this is what SolidWorks does when it can't find a file. You open an assembly, it can't find it. It will go through these 8 steps to try to find it in the different locations in case you moved it and didn't tell SolidWorks you moved it. Definitely look this up. There are some great resources online that really go into depth on this. This could be a presentation of it on its own. But to jump into the first tip here, we have Jill Designer being told by Lucas Engineer that there's a new updated version of a component that needs to be placed in the assembly. So Jill is going to take that component and place it onto her desktop. That's about the worst place you could ever put a file, is your own personal desktop. But she's not familiar with any of these good practices. So she has to go ahead and place this into the assembly. Now we're working with a sewing machine assembly in this case, but this is applying to any assembly really. She'll go ahead and open up that component. The only thing that's really changed is they've gotten rid of the fillets on the corners to reduce the manufacturing time, but that now has to be placed into the assembly. Could have just worked on it from the shared location, but there is no shared location in this instance, and it's just really bad practices. Now, as she's opening it, she sees what was there last in the preview. The graphics haven't updated yet. Now, she already had this open, so it was open in SolidWorks or in your computer's memory. So since it had the same file name, it pulled it in automatically. She thinks that's great. She doesn't have to do any more work by replacing it into the assembly. However, switching over to Lucas, now when he opens that, he unfortunately doesn't have access to Jill's desktop. So now when SolidWorks goes through its references and tries to find that file, it will actually go through that search routine. In his case, he had the old version of it somewhere in one of those 8 steps. So it just reverted right back to that old version. So to either of them, they both think that they've done something right. And now neither of them know what went wrong. So understanding those file references could cut down on a lot of that back and forth and just make sure that that is streamlined and done right the first time. And to demonstrate that workflow, jumping into my second one here, this is more of a file management. So just using, understanding those references, we have to go and update where that common shared location is. So in this case, instead of the desktop, we go to the shared project folder where they both were working from this whole time. And since there was already a file there, we overwrote that version. That's something to be aware of on its own thing. Be aware of what you're overwriting. But in this case, now when she opens this from the location here, it goes through that search routine. You overwrote the file that was there. Since it has the same file name, it will pull that right in, just like it did last time. But in this case, it's pointing to the right direction that Lucas still has shared access to. So switching over to his case, when he opens this up, and now we'll go through and update. And in this case, you see it in the preview because it was saved with the preview. But by the time the graphics are updated, it will be connected to the right part for everyone. Now, in terms of data management is really just file management with foolproofing built into it. So in this case, Jill did add it to the desktop, which nobody else has access to. But in a data management system, everything is built into the database of the management system in general. So in this case, we open up the part and we can use a replace command, and then we can choose a local copy to replace the version that's in that database. What this will do is then, and technically, in this case, even if I had it open in my computer's memory, as I showed in the first example, it would have a similar outcome as this replace command. So in this case, that is now checked into that system. Same thing happens when you go to the assembly, it updates it. You can then check that assembly into the system as well to make sure everyone else that has access to that has the latest version. And now when Lucas opens this up, it doesn't look for that local file location. Well, it does. It looks for a local copy on Lucas's computer. Any file that it doesn't find, though, it'll pull from the database rather than ask you to fix it. Otherwise, if it can't find anything, which in data management, it will always find something as long as it still exists, unless you deleted it. But if it can't find anything in the file system, it's going to ask you to go and find it for SolidWorks. It's going to bring up the dialog, browse for files. So tip number 2, SolidWorks file utilities. For anyone getting started with SolidWorks especially, this is more so how you keep those references. So number 1 is understanding how the references work. Number 2 is making sure they're maintained. So SolidWorks File Utilities is installed with SolidWorks. It's available on the right-click menu of Windows File Explorer. So as you go into a part and you want to say rename it without breaking a reference, you can right-click, hover over SolidWorks, and select the rename command. There's a number of other commands there. Windows 11, you may have to go to show more options and then over. But this will be a lifesaver when it comes to maintaining your references and keeping everything intact. So in terms of this situation, we have Lucas asking to source out a very specific part number. All parts were initially named with a pretty generic name. No specific actual manufacturer part number was included. In this case, Joe went to McMaster to find that specific part number that will actually be used in the manufactured design. Goes in, copies that part number, and then just pastes it over the file name without telling SolidWorks that's been updated. So in this case, when Lucas goes to open that assembly now, unfortunately, SolidWorks was never told if that part number changed. It goes through all the locations to look for the original part name and can't find it. And that's that browse for file dialog I was talking about. It's going to ask Lucas to go find it, which Lucas doesn't know what that new part number is. So now there's time lost going back and trying to find what that part number is. So it can really be a lot of back and forth of time, non-value added time when you don't implement proper practices. Now, in terms of just using your file management techniques that everybody has with SolidWorks, we can take that part number and instead of just pasting it over inside of the File Explorer, we can use a right-click menu, rename, and then paste that part number into the File Utilities rename command. Now we can see it updated there, and then when Lucas goes to open it, you'll see that it will go through with opening the assembly. Now, I did add a little bit more here, just as an FYI. If you work with, and you can't see it here, but these are in lightweight mode. If you work in lightweight mode, it might not update until it's resolved. So Lucas pans over to this component here, and it still has the old name. Oh, there it is. You can see that's in lightweight mode. As soon as that's opened up, though, it will update. So that's something to be aware of with lightweight mode. And if you're working with renaming components, make sure you resolve components to see all those changes. Now, in terms of data management keeps all of its references a lot more in the background rather than just inside the file name. And it is ultimately in the file name, but it has some ways of working in the background that it doesn't break those references as easily. So in terms of the data management, you can just go in 3D Experience, specifically the field is called title. And then you just update that and it updates it in SolidWorks and everywhere else it's used without breaking the file reference in the background. And then just rewrites all of the title everywhere that's used. And then that's checked in, and then it can be used in assemblies downstream. Now, tip number 3, part numbers. This is often something that an organization already has set up in some degree, but it's definitely worth evaluating from time to time if it's working for your organization. There's a couple different ways to set up part numbers. Being intelligent and non-intelligent are the two primary. Intelligent being has some kind of key. So you may have some kind of suffix for certain manufacturing process, whatever it may be, where non-intelligent is just maybe a random string of numbers. Intelligent is easy for communicating. Non-intelligent takes less training. So there's a give and take in terms of what system is best for you. A data management system makes it easier to use non-intelligent because you can source all of the metadata and information inside the system, whereas some people need that part number to have that. So if they send it off to vendors, whatever it may be, that people have an understanding of what that part number represents. But if you're using the wrong part on accident, if you don't have any part numbers, definitely get some kind of scheme in place because you need to have some type of unique identifier for every item that's going through production or other, it can be pretty costly mistake if you send the wrong part to manufacturing. In this case, we have me a manager introduced into the situation, asking for the presser bar lift bracket component. Now that's a pretty generic name. Lucas goes and asks for the bracket that goes with the presser bar to Jill. Bit of a telephone game here, and now we've lost part of that translation in this. When Jill goes to search for that, she doesn't have a specific number to look for. She just has a kind of a generic description. Goes in, does the best she can by searching for the presser bar bracket. That comes up with a number of bad, messy solutions here. This is a bad organization. But she chooses the presser bar bracket rather than the presser bar lift bracket. So if you're using generic names and there's two real close to each other, it can lead to a really easy miscommunication. Now, in terms of just having a part numbering system in general, whether that be through an Excel spreadsheet, however you're managing that, you at least get a unique identifier for every component. So now instead of it being a generic description going through and asking somebody to pull a specific part, you are able to go through and ask for a specific part from somebody. So in this case, there's no real telephone translation loss. We're able to jump right into our file system and search for that, and then pull that exact part in. Now, with data management, you can add a second layer of part numbering. So whether it be serial numbers, in the case of 3D Experience, it's called enterprise item number. So you can keep that generic description and title there, but you can add a second layer of part numbering once you get something to production, so that you have 2 layers of searchability. You can search that original kind of descriptive title, or you can search that part number. So we have Lucas adding a part number here to this part. Now we'll go ahead and check that back into the system. Now, jump forward a few weeks when that request comes in, we're able to carry that same part number, hand that over to Jill. And another thing with data management is generally the search, you're able to search your entire organization's data set. You're not just searching one folder. And you can, of course, do that with a file explorer too, but it might take a lot longer versus 10, 15 seconds to get all the results. So here we can actually see the descriptive name. And we know, even though we searched that specific part number, and then in SolidWorks, if you did want to see that part number, that's just a matter of changing your settings to see whether you're seeing the descriptive title or whether you're seeing that enterprise item number. You can see here that it's the item number now. Now, along with part numbers, same thing with organizing your data. If you just have one folder with a bunch of different projects in it, that could lead to a mess. If you have different organization for each different project, that can lead to a mess. You need to be able to have a consistent way to find data regardless of who you are searching for what data. And there's also a balance though. Don't be layering 10 different folders inside of each other. You can end up with a super long file path that actually gives SolidWorks issues if you have 10 different folders layered in each other. So in terms of having no system, we have Jill here. Can't see the name, but it's top secret concept with top secret name. She's not shared this with anybody. She's not shared where she saved it. So this is saved technically in a shared location. Unfortunately, she went on vacation. She's not available for the next week. And MeetUp manager is asking Lucas for an update on this for the investor meeting tomorrow urgently. And she needs that by tomorrow. Lucas goes into the folder structure, starts searching through it, but unfortunately is unable to find wherever Jill saved this file. And goes through a number of different methods to try to find this. Now he spends his evening remaking this part instead of being able to go home. Now, in terms of just file management, this is a standards thing. It's just a matter of talking to your organization. And you could have something like this where you have an archive CAD folder, a non-CAD folder. In your CAD folder, you could have a concepts folder. And he's able to dive into that project and find that data really quickly rather than spending his evening in the office recreating work that was already done. Now, in terms of data management, this is just another example of how you're kind of foolproofing the file management system. We're re-highlighting the search capabilities here. So in this case, he still doesn't know where Jill saved it. Fortunately, he can use advanced search capabilities to filter through that data. So in this case, he's able to search for physical products, which is just all 3D and 2D CAD data. He's able to choose the modification date because he knows when Jill last worked on this. And then he can go in further and choose specifically who the owner of that data is. In this case, it's Jill. You can filter out by all sorts of properties, manufacturer, material, however you want to do it. But what this does is it allows you to go through an entire database, which, for example, this database has hundreds of parts and maybe even thousands. We have 4 parts that come up. So even though it's not giving you the exact one necessarily, it's going to bring your list down a lot more and give you accessibility to find that data when you need it. Oops. I have a little bit. Tip number 5, library components. This one is also another thing you have to be careful of, but it's good to know about. So if you have fasteners or any components that are used in multiple products that you want to keep consistent, creating a library or location for library components can be really beneficial in making sure that you have consistency through those projects. You also have to make sure that you have the right people with the right access to those, because if you do use library components and one person changes it accidentally or deletes it accidentally, it can throw out a whole list of products that it's used in. But if you do have this set up right, it can provide a lot of power in terms of your data reuse and making sure that you're able to have consistency across those products. So taking a look at the no system here, we had a design review and we want to add some ridges to the hand wheel with this design review. Now, Jill opens up their products folder and they have a number of sewing machines they're working on simultaneously, searches for that component and can see that it's used in every single one individually. It's a copy of that file. If she wants to make a change, she either has to do one of 2 things: go through and change each one of those and make sure they're all consistent, or change one and go and replace it in all the assemblies and make sure it's proper. Now, that's really the only option. It's just a lot of wasted time in that case. Now, in terms of just using your file management side of things, you can set up a common location in your network drive, whatever it may be, that the components are saved in, that everybody has access to. Again, it's good to have control over this so that somebody doesn't go in and just delete this. And you can even add this to your design library so that it's just a click and drag for those common components, kind of like SolidWorks Toolbox if anybody utilizes that. So in this case, Jill goes ahead and opens that up, makes a change. Since that component was used from that shared location, it's already updated in the assembly. It would also be updated in any other assembly that component was used in. And again, you just want to, and any assembly moving forward, as we can see here. You just want to make sure that the right people have the right access. Now, jumping into data management, specifically 3D Experience has a little bit more flexibility with how it has items and folders. In this case, we can see this has a unique identifier. I believe that's 1909, something along those lines. That is a unique identifier that nothing else in this database has. So it's unique to that item. Just to demonstrate, if we copy and paste that to a new folder, even though it was a copy command, not a cut command, and then we go back to those properties, we can see that it has that same unique identifier. So this is actually in a database in the background. These folders are just kind of links to that. So you can have the same item show up in all your project folders to keep it visible in that it's in that project, but it's still a unique item. You change it in one place, it's a single source of truth. And we can see that here. I'm jumping into a where used view. Even though I just copied that item over and I expand the parent, it's already showing that it's still related to that parent assembly that we have open right now. Now, this one is hard to do without a data management system. This one is especially hurting you if you're working off of a network drive with a VPN. So if you are working off of a network drive, you're going to have longer save and open times regardless. You might not notice it if you're on site, especially if you're working with smaller parts. Even if you're on site and you're opening bigger assemblies, you're still going to notice working off of a network drive. If you throw a VPN into that mix, you're really going to notice. So hard drives are great for speed, but they're also prone to corruption. If you lose that hard drive, you lose all the data on it. So there's a balance that you have to drive there. There's 3 main options for storage. There's just your local drive, again, speed, but prone to corruption. 2 is network drive. You have more settings to control this backups and the permissions, but it can take a slower open and save times. And you are more prone to corruption if you're saving something that takes a long time to save and your connection drops, whatever it may be, you're more prone to corruption in that manner. Cloud storage, in terms of just like Dropbox, Google Drive, you can turn off the syncing locally if you want to make sure there's no corruption, like you're not trying to save while it's syncing and there's nothing happening there. You could pause the syncing locally or pause the syncing to work locally. However, that takes a lot of communication if you have 2 people working on the same project to make sure that both people don't make changes and then turn their syncing back on and override each other. So in terms of file management, you either have to take the hit on speed and just work off of your network drive, or take the chance on your hard drive, or you can do a little bit of both, but the situations are limited. Like one example is actually copying and pasting files, the whole file from a network drive is faster than opening it and writing to it directly. So theoretically, you can copy and then overwrite the one on the network drive. This is easy with a single part, but it gets really challenging when you have a whole assembly that you only change one part on, knowing which part changed, which part to overwrite back. So there's pretty limited scenarios in which that is an efficient workflow. And generally, a single part isn't hard to open and write from a network drive to begin with. It's the big assemblies that cause the issues. And then the pausing cloud storage is another one that I already mentioned. You just have to be aware of cloud storage generally syncs to a local user profile. So we can get all sorts of broken references because it saves to that local user's file path, and then another person opens it and can't find them. So there's ways to overcome that, but none of them are just easy out of the box solutions. And data management is built to do that. If you open something from data management that caches it locally on your hard drive, then you push those changes back up to whatever it is, whether it be your servers for on-premise or pushing it back up to cloud storage for cloud data management. Now, tip number 7, I've already alluded to this as well a little bit. You want to make sure that you have the right accesses and permissions for everyone in your organization. Make sure that nobody can just go in and delete or edit things that they're not supposed to be touching. Especially if you have somebody new in the organization, they're not familiar with the standards or projects. You don't want to have any lost work in that manner, especially if you don't have any past versions saved. So this can, especially that last scenario I mentioned, can save you from hundreds of lost hours if you have somebody go in and change something that you don't have any backup of, that's gone. With no system here in general, Jill was tasked with cleaning up her concepts. So goes in, grabs the concepts, accidentally grabs a non-CAD folder along with it, hits the delete key, and then carries on with her work without noticing. It's a matter of a couple of days before they realize that that folder is gone. If they have a network drive with backups, they can get that, but that's still lost time going back and restoring that backup. If they don't have a backup, that's gone forever. So with just a click of one single button without the right permissions, that could be hundreds of lost hours. Now, in terms of just setting up some simple file management permissions, if you carried out that same workflow with constricted permissions of deleting of certain folders, get a warning where you may need administrator permissions. That at least signifies whether it be unintentional or intentional trying to delete that data, signifies what can be and cannot be deleted. Now, taking it a step further, data management, you of course have the same permissions, but in this case, if I try to delete this part here, I'll get confirmation that I want to delete it, but then I'll get a warning that I can't delete it because it's referenced in other assemblies. So you can even have it set up so that if it's used in any assemblies, it can't be deleted until that reference is fixed. And of course, you can just stop certain people from deleting anything and have all sorts of different workflows. So there's a lot of permissions in terms of who can see what, who can edit what, who can delete what, that you have a lot more nuances with data management systems. Multi-user environment settings. This is another thing that data management really specializes in, and it's built to do, whereas other things you can do, but they're not really meant to do that. SolidWorks did introduce, it's been a while, I believe it was around 2013, but they did introduce some settings that help facilitate collaboration if you're working on the same assemblies. But again, they're kind of workarounds and they are limited in their capacity. In terms of those settings, they're under system options, collaboration, enable multi-user environment. They give you commands such as read-only, get write access, read-only, check read-only files and reload. Make read-only is essentially just sending a flag to everyone else that it's read-only. They can get write access if they claim it to make changes, but it's read-only right now. Check read-only files. If you have an assembly open, you can check if the files that are currently read-only that you have open, you can check if anybody's changed those since you've opened the assembly. Get write access means you're going to be making the changes on that. So you claim write access for your user. And then reload just pulls in the latest versions if somebody else has happened to make some changes to some read-only documents that you've been working on. This doesn't 100% restrict people from saving over read-only files depending on your permissions. So again, it's not foolproof, but it does help facilitate that. Again, data management, that's built to do that. So it's, you just right click, lock it to your user. Everybody else can see you're working on it. Nobody else can make any changes to it. So it's really built into the lifeblood of the system in general, regardless of what system you're working on. Engineering release is another aspect that goes along with permissions. Once you get something to production, you don't want to make any changes to that without signifying a change has been made in the new revision. This, again, is something that basically collaboration, revision, and engineering release are the three big things that data management does that's hard to enforce without data management. The other things you can implement some type of process, but those three things, and even revisioning, you can do, but it's really hard to have it enforced and clean. In terms of, I forgot to update the header there, but in terms of things you can think about with engineering release or just working on SolidWorks, one option is in 2023, they introduced the option to show on open with comments. So you could add a comment that says, this is released, don't make any changes until the revisions change, and then have it pop up every time somebody opens it once it's released, just as kind of a sanity check that people are seeing that, but it doesn't require them to change that revision. So that's more of just kind of a warning flag that you can throw up that tells people that it's been released. Another thing is just right clicking and going to properties in Windows File Explorer. If you have the right permissions, you could make it read only so that if somebody opens it up, they see that it's read only. You could pair these two things together to get somewhat of a release workflow. But again, unless you have everything locked down quite right, people could still go and overwrite read only data, and it doesn't really enforce it. It's just pointing people in the right direction. Now, in terms of data management, I did show this one in the video snippet. We have in work state here, which means people are making changes to it. It's just a matter of switching it over to a released state, which now, once that transitions over to a release state, if anybody goes in and, in this case, Jill, tries to lock it, which means claiming ownership to make any edits, it's going to throw a flag that can't proceed because it's not in a good maturity state. So either somebody would have to change that maturity state or create a new revision. And that's where it really gets enforced by the system. Which leads me to revisions. Those two go hand in hand. In terms of revisioning, you need to make sure that if there are changes, the documents you're sending to your manufacturing floor or whoever's reading off this engineering documentation, they know which version they're looking at. So if you've made changes, they need to know they're looking at that latest version. It's hard to enforce. So you can have practices set up internally that you may put it in the properties. But a couple of things to consider. If possible, keep your latest live CAD data in one location and don't change the name, because then you won't ever deal with broken references. If you're going in and adding like _rev_a to your live CAD data assembly, unless you really are familiar with SolidWorks references, you can break those. If you keep one version, the latest, in one location, you won't deal with those broken references. In terms of making sure that that's documented, you can take, once something is released, and export it to an archive location, and then you can add those suffixes to that archive export. You can just do steps in PDFs if you want to just have some type of record, or you could do the entire pack and go of the SolidWorks assembly to make sure you have all of that. Now, like I mentioned, you can keep the revision in the properties, the file properties, or you can put it in the file name, but I would recommend only doing that in your archived copy that you're saving off. And that gets hard to do with the pack and go. You can add a suffix and you could just add it to the whole assembly. But all that's going to tell you is that all these components belong to this main assemblies revision. It's not going to go through. And if you have one part with Rev A and one part with Rev C, you'd have to go manually do that, and it would become tedious. So theoretically, you could export everything at Rev B of an assembly. You know that that part goes with that Rev B of that assembly, and you go into the bill of materials for that assembly drawing, and you go that route. But there's no clean way to really do that. So in terms of data management, this is another one that I just was demonstrating video. You can see that it has Rev E there. As we go in, we try to edit it. We see that it's released now. So we get confirmation of that engineering release. We can just click new revision. That'll bring up a preview of what revision is going to be next. And then I'm able to go in and create that new revision and pull it into my system. All past revisions are stored, so you can always go back in history and see what revision is, what state of the design. So we can see here it's locked to my user. I can now make changes. I also can always, as I mentioned, see a history of what revisions existed and then pull those up.
I have a question on your 3D experience. So, like, let's say you're doing ECOs, you're going to manage it electronically. You can do all that with that 3D experience.
Yeah, so there's a couple of ways you can go about it with 3D experience. You could have your own manual process for the ECOs and just drive the revisions here. It also has change management tools built in that enforce it even further. So with the change actions built into the system, you can attach certain CAD data. And then as soon as you assign somebody to that change action, they're the only people, whoever's assigned, are the only people that can make changes to that CAD data while it's under that change action. And then you can assign certain approvers to that change action that are the only ones that can release it. By the time those approval routes go through, everything automatically trips to release. And then unless you toggle it, it'll actually require another, moving forward, it'll require another change action to even create another revision. So you can lock it down however much you want. Now, we wrapped up with our main 10 tips. Just as a last roundabout here, these are all just recommendations. Everybody's going to have something specialized for their processes. Some things might work, some things might not. But really, it all comes down to having a standard process. Even if you have a data management system, all that's doing is taking the process you want to implement and enforcing it. You can do a lot of these things with a file-based system. You just need to make sure to have this documented and make sure that your users are properly trained. As just a summary, make sure you understand how SolidWorks references files, utilize those file utilities to keep those references intact, define your part number scheme to make sure you're communicating efficiently with your organization or externally, create a central locate or define structure for storing your data to make sure everybody can find the data they need when they need it, create a central location for library components so that you have efficient data reuse, store your files externally and work locally depending on your workflow. If you're working with large assemblies, it may be something worth considering, or just in general, how you want to make sure that you're having the most efficient workflow with opening and saving data. Control data access and permissions to make sure the wrong people aren't touching the wrong data. Utilize multi-user environment settings especially if you're working on the same assembly with multiple different people. Creating a defined engineering release process to make sure that people aren't changing things that have already been set off to production. And then create a defined revision process to make sure that it's documented which version is which when it comes to the documents they're viewing. So in terms of what's next, if you don't have anything, get started on just taking a look at some of those practices if you can implement them today. If you're already using those file management systems, it might be, and you're running into problems still with data reuse, whether it be communication, it might be worth evaluating a data management system, whatever system that may be. If you are using data management and you're still having problems, there's probably something you could do to improve your workflow with that further. So whoever you're working with that data management system, get in contact with them and see if they can help you out improving your workflow. In terms of the data management options that SolidWorks deals with directly under Dassault Systems, 3D Experience is my specialty. That's actually a Novia-based data management. If anybody's familiar with a Novia, that's when I said 3D Experience is just a family. They've taken a Novia data management and hooked it up to SolidWorks is the big thing there. That's all cloud-based, so you don't have to have server infrastructure or anything for that out of the box. You can tweak the settings, tweak the revision scheme and all that, but you can get up and running. You don't have to host it. SolidWorks PDM is another option, which you can host locally on your own server hardware and maintain that with your own internal department. That is hosted on your local servers, so you have to keep those up to date. But that is an option as well that provides these capabilities just in a slightly different way.